July 23rd, 2016. This is the X-ray flux chart from Boulder, Colorado, the 3-day plot and the 6-hour plot on the right. These two spikes, the last two large ones, almost hit X flare, the very strong M, a 5 and a 7, and those are the strongest of 2016 so far. We watch these because many times I've seen them create large earthquakes on this planet. Now these are off to the right, the two sunspots we've been watching, just as they centered the Earth's magnetic connectivity point with the sun. But look at what's happening on the ACE satellites. These are electrons and protons that are crossing it. Remember, ACE is an early warning system for our planet. Even though the two flares associated with these, the two coronal mass ejections associated with the flares are to the right. They expand outward, and we will feel the impact. If we weren't going to feel the impact, they would not cross the ACE satellite before, which again is an early warning system for our planet. Check this out, guys. Strongest of the year. Very impressive. Slow it down, pull it up in a zoom. Here's your first flare. Check that out. Very impressive. What you're seeing in that classic X is the optics overriding on the cameras. We'll do it on every camera because it's so intense. And guys, you could put about 20 of our Earths between those sunspots right there. That's amazing, the size of it. The same satellite, different camera. These are Solar Dynamics Observatory images. What this does is allow you to see the flare, but also the associated coronal mass ejection thrown out off the surface of the sun. Quite a bit happening today and yesterday. This filament released right there, and that in itself releases quite a bit of energy. You've got another filament bottom right. The one on the top left, if you notice as this goes forward, it will release, and then you'll see a lighter area expand outward from where it collapses back into that filament channel, and that's a secondary energy burst called a Hyder flare. A lot going on here. But to the right now, that is what we're looking at, these double flares, and there is your coronal mass ejection. Check that out. That's the surface of the sun being ejected at hypersonic speeds off the surface of the sun. If that was Earth-facing, that would be classified as a possible kill shot. I'm going to show it to you from a couple of different angles. That much plasma concentrated in that tight of space crossing a planet could devastate the atmosphere. It could cause massive blackouts. And we're already in one of the worst heat waves we've seen. Look at the amount of energy. Again, guys, you could put maybe 100 of our planets in that section of that explosion there that you see as it comes out. And if you just squared that out, that's how much energy. It's amazing. We're going to look at it on both Glasgow C3, C2, and we'll take a look from the backside of the sun from stereo B. Again, here's your filament. As it releases, you'll see that lighter area spread out from that channel, and that's a Hyder flare. Doesn't seem that impressive, but the amount of area that is part of this is large. Here's your two sunspots. Remember the video I did yesterday, or day before yesterday, the last video, where the Earth's connectivity point was right between those sunspots, guys, the magnetic connectivity point between the Earth and the sun. Let's change satellites and go to Glasgow C3, very wide image. Guys, the size of the sun is the white dot in the center of the black dot, to give you an idea when you see these explosions, and then you compare that to the size of our planet. But this is the burst here. That was the plasma density that would cause disaster if it were to come across our planet. That's how impact it was. Same satellite close-up camera of Glasgow C2. Check this out, guys. I'm going to slow it down because it moves very fast. Just to give you an idea, again, the red circle is an occulter disk that blocks the glare of the sun so we can see the outer edges. But the sun itself is the size of that white circle. It would take 109 of our planets placed inside that circle to go across the surface of it. There's your first flare, the M5. Then you've got the M7 point plus. That was the strongest of the year coming up here. And the bottom sector, that amount of density there And that small speck, guys, is about the size of our planet, if not larger. But you can see as it expands outward, that's one clump. It's like a clump of lava. But it's protons, electrons, it's plasma. Let's go to the other side of the sun. Stereo ahead picked it up. It looks like it's on the opposite side. Makes sense. It's on the other side of the sun. But the optics on stereo ahead are not that good, but you saw it very clearly. Now, this proton flux monitor, all of these are on our website, by the way, is coming from the GOES 13 satellite. That never rises unless you have extremely strong flares or a very powerful comet coming into the inner solar system. I've watched it for a long time. But they're saying these departing sunspots have caused the strongest flares of 2016. The second one was an M7.6. It was the strongest flare, and they were very close together. Now, I always go and watch the earthquakes when we start seeing this type of activity. You've got kind of a triangle here of fives between Mexico, Alaska, and just north of Japan there, between Russia and Japan. You see that? A couple of other ones across the planet. Nothing large at this time. Let's watch that because a couple things are happening. We have the shields are weaker because solar minimum. We saw a lot of damage last year to our shields, and I, again, can attribute that to CERN because we saw it collapse when they're running these high-power experiments. What we've seen this year, after a shutdown of the magnetopause, that was as it was collapsing in the we saw a reversal of the solar stream. After the 4-day shutdown, it came back up, and it seemed a little odd. But during a solar minimum, what may be happening is we look at CERN. It's running at 6.5 TeV per beam. That's as high as it is supposedly allowed. Gives it a 13 TeV collision point. Here's your beams. Notice how tight they are. That's because they're running at high power. When you see them larger, it's a slower run, but the tighter and the faster these things get, the smaller this beam will appear. They're getting it concentrated for these collisions. But what I'm saying about CERN and solar minimum is it's almost like the Dr. Frankenstein scenario. They're waiting on lightning to energize the machine, if that explains anything at all. But look at the beams right here. The black beam is the total energy running at 13 tera electrons. Your blue and red are the individual beams, beam 1 and 2. Those are beam intensities, but the black beam is beam energy. Again, 6.5 per side gives you the 13 TeV. Now, the whole deal is the number of collisions at the highest power possible, and that's called luminosity. Atlas, the largest machine ever built, has way more than delivered the targeted luminosity. The targeted is in the red. Anything above it is in the green or below it, but you can see that Atlas and CMS both tripled the relative luminosity that was targeted. Now, that's if these scales are linear, but look at the, this is the coordination and the planning. They're running 2,076 bunches at a time, both at 450 GeV, 6.5 TeV. Now, let's go back to the Frankenstein scenario. We're getting energy, and many of you have seen this before, from outer space as the solar stream and these flares hit the magnetic shields of our planet. It's delivered to the surface of the planet through what's called the Peterson currents. They're line currents. That's one coil. We're dealing with 3 coils, 4 if you include the sun. Peterson currents come down and interact with another coil. It's called inductance. If you haven't studied electricity or electronics, it hits that coil. Then there's a coil inside CERN that's 17 miles wide. The largest machine ever built is inside that again. But you're dealing with coils. On the left, right there in the very, just say that's CERN. Then you've got your different magnetic lines of flux. You've got the Hall effect sensor on the other side. And just like the transformers that are on your electrical poles outside, guys, you've got possibly 880, 440 volts coming down the line, and that's a step-down transformer, so it drops it down to 220 to come safely into your home. It can go the other way. You can have a step-up transformer that will take power from a small coil and put it next to another coil, guys, that has more windings, and it's a step up. It gives you more voltage. Again, because we have not seen the effects on our magnetopause that we've been seeing, that may change, because now they have energy to work with. I don't care what they say. I understand electronics too well. I took it in college. I took broadcast communications. I understand how these waves, how these magnetic currents work, and that's exactly what's going on. But what you were looking at was this, all of this is building into this atmospheric heat dome, guys, and the sprites are becoming more and more visible from the ground. Now, these are this month, and what you're looking at is energy from the upper atmosphere and striking the atmosphere, transferring energy down to cloud tops that could be hundreds of miles from this guy's taking this picture, Martin Popek, back on July 10th. And then you see a V that's coming up off these sprites, guys. That is the energy that clouds cannot absorb, and it shoots back up and explodes through these sprites. But now they're becoming more and more visible. There was not even a photograph of these until '96, and it was from an airplane, guys. But again, in the U.S., Russia, Europe, we're starting to see more and more of this energy. So as we're seeing the heat build up, the compression build up, this energy being pulled into our planet, you're going to see extreme storms and extreme lightning. You're seeing that already. Floods, record heat, record lightning, people getting killed. And I'm afraid the winter, because of the extremes, is going to be the same way. People say it's global warming. It's not. It's global extremes in both cycles because the tilt of the magnetic field. We're watching it, guys. It's a heads up. Be safe.